We have a track that is set up on a pivot, and we have found pretty much the center of mass of the track so that its weight and there's no imbalance in the forces of gravity pulling on it. Now that's a delicate balance. We don't have to add much to the system for it to become rather chaotic and to throw our center of mass calculations off. Now if we add two objects to this system, even if we do find a perfect equilibrium, the slightest disturbance will tilt it all. So keeping that center of mass right at the pivot is more challenging than it looks. So with this setup, we took two carts and gave one a mass that was 3 times greater than the other, so the red one has 3 times the mass. We set them next to each other on the track and found a position at which everything balanced. Watch what happened when we released a spring plunger to have one cart push away on the other. There are a couple big things that I'd like you to notice other than my clumsiness. First, you can see that the red cart, with 3 times more mass, moves to the left at 1/3 of the velocity of the blue cart. This makes sense since its momentum in the negative direction, mass times velocity, needs to cancel out the positive momentum of the blue cart. Why do they need to cancel? Because with no outside forces, the total momentum for the system should remain 0 from the time before they pushed apart. This holds true until the blue cart hits the end of the track and experiences an outside force. Second, remember that the fact the track balances indicates that the center of mass for the whole system is located at the pivot point. This remains true even though the two carts start moving. If no outside forces influence the system, the center of mass still has a velocity of 0, until the blue cart experiences that outside force, at which point the center of mass moves to the left of the pivot, and the whole system starts to tilt. The leftward push on the blue cart also pushed the center of mass of the whole system. Take one more look at the whole sequence. At this point, if you haven't watched it, I also encourage you to look at the Push Me, Pull You demonstration video created by the folks at MIT. Thanks for watching.